Now let's look at section 9.6, factoring when a is not equal to 1. Remember, a is the coefficient on the x squared, b is the coefficient on x, c is the constant. So let's look at a problem like this. This one would be easy just to be done by what we would call trial and error. Remember, it's going to factor into two binomials. The only way this will factor is 3x and x. The only way the 5 will factor is 1 and 5. Since you have both positives here, both of these numbers would be positive. There's no need to really look at -1 and -5. So let me do it incorrectly first. If I put the 5 here and the 1 here, when I checked my outers and inners, remember we are going to check by FOIL. When I check the outers, I have a 3x. The inners, I have a 5x. That equals 8x, which is not the 16. So what it should factor into is 3x plus 1 and x plus 5. Now when you check it, you have 3x squared. You have a plus 15x plus 1x plus 5. So the 15 plus the 1 gives you 16 in the middle. This is the correct factoring for that problem. Some of them are done easy by just trial and error. But let's say that you have a number that has more factors, and we don't want to take 10 minutes trying to get the thing factored. So let's take the problem 2y squared plus y minus 10. Now the first thing we're going to always tell you to look for, so we might as well start now, is to look for a GCF with all of the numbers. A 2, a 1, and a -10. There is no GCF, so we will factor as is. Multiply A and C, which is 2 and -10. That gives you -20. Now, write the factor pairs that will give you a sum or difference of a 1. Now, we're going to need one positive and one negative because it's -20. So I could do 1 and -20, -1 and 20. Well, that won't give me a difference of 1. Let's try 2 as a factor, so let's try 2 and -10, -2 and 10. That will not give me a difference of 1. 3 is not a factor, 4 is. Let's try 4, -5, -4, and 5. One of these pairs will give you a sum of +1, which is this pair. So we want to set this up as -4y and 5y. We are breaking this term down. 2y squared plus -4y plus 5y. I'm going to write this as plus -10. This together is the 1y in the middle. Now we are going to pair these factors. We're going to pair the first two and the last two together. They will have a GCF that we will factor out of each pair. If you look at this, they both have a 2, they both have a y. So we're going to take out a 2y. We would be left with y plus -2. So let's check that by distributive, 2y squared plus -4y. This pair has a 5 in common, so we take that out. We have y plus -2. 5y plus -10, so it's correct. Now, if you notice within each pair, you have a common factor that is a binomial, meaning two terms of y plus -2. We factor that out, and we're left with 2y plus 5. That is the way the original problem will factor. Now, always make sure to check by FOIL. So let's multiply the first, 2y squared, plus the outers are 5y, plus the inners are negative 4y, and the last would be negative 10. When we add that together, the like terms in the middle, and this is what you get, or you can write it as minus 10. It's the same thing, so that is correct. Let's take a second problem. And let's see, 6c squared plus 7c plus 2. You may want to pause the video along and try each step yourself. We could do this by trial and error, but I would have a possibility of 1 in 6 or 3 in 2, and then I would have 2 in 1, 1 in 2. It's a lot of trial and error possibilities. So, remember, we multiply A and C, which is the 6, that's the A, that's the C, and we get a 12. We need to get factors of 12. That would have a sum of 7 in the middle. So we would try 1 in 12, and let's remember negative 1 and negative 12 would give us the positive 12. But we're not going to need negatives because both of them are going to be plus, since the middle term is positive and the last term is positive. So let's try 2 and 6. We don't really need to look at the negatives. That does not give us a sum of 7. The next factor pair would be 3 and 4. That gives us a sum of 7. So let's break 7c, the middle term, into 3c plus 4c. Now let's take 6c squared plus 3c plus 4c plus 2. Pair the first two and the last two. And let's take out the GCF. These both have a 3 and they both have a c. When you take that out, you're left with 2c. That gives you 6c squared plus 1. So when you distribute 6c squared plus 3c plus the second one, these have a 2 in common. When you divide out a 2 or factor it out, you have 2c plus 1. 4c plus 2. Now if you notice, the binomial is the same, 2c plus 1. When you factor that out, what's left? 3c plus 2. So that is the way that the trinomial factors. Now, I will double check because you need to at least be doing this in your head, if not on paper. Let's take this in FOIL. The first is 6c squared. The outers are 4c. The inners are 3c. The last is 2. We add the middle terms together, they're like terms, plus 7c plus 2. And that is what the original polynomial is, so it shows me that I do have the right answer. If you have a problem that leads off with a negative, negative x squared minus 3x plus 28, you need to first factor out a negative. Take a negative 1 out of the entire trinomial. That leaves me a positive, a positive. This one will become negative. Don't lose the negative 1. That is part of the factoring to get back to the original trinomial. This will break into 2 binomials. We know that this will again break x and x. And we know with this being a positive, actually that's a negative number there. So we're going to need a positive and a negative. So let's take again, we multiply our A and this C number. A is 1. We're looking at this right here. C is negative 28. So to get a negative, when we break down the factor pairs, we need one positive and one negative. So we would have 1 and negative 28, or negative 1 and 28. 2 is a factor. We would have 2 and negative 14, or negative 2 and 14. We're looking for a sum of 3 in the middle, so we can break that down. 3 is not a factor. 4 is 4 and negative 7, negative 4 and positive 7. That gives me a sum of positive 3, which is the middle term. So I am going to break this down into x squared plus negative 4x plus 7x plus negative 28. And I was showing you here about factor by going ahead and trying to factor that, but let me cover that up because now I need to group these. And don't forget there was a negative 1 out here. So let me rewrite what we have here. This is not neat. Don't lose the negative 1. So we're going to do brackets. We're going to pair these two together and the last two together and close your bracket. I'm just going to slide this up so we can see the original problem. Again, don't lose the negative 1 out front. It is what will get us back to the original problem of negative x squared when we're finished. The GCF of each of these, this would be x plus negative 4. That gives me x squared plus negative 4x. These have a 7 in common as a factor, x plus negative 4. Now you'll always notice your goal is that when you factor out the GCF, the remaining binomials will be the same. So we have negative 1, x plus negative 4, which can be written x minus 4. That comes out of each pair, meaning this and this. What's left is x plus 7. So that's the way your original polynomial factors. When you multiply it by FOIL, let's go over here and do the check. X squared plus 7x plus negative 4x plus negative 28. Now join the two middle terms, x squared plus 3x minus 28. But if you remember, there's also a negative 1 right here that we have to multiply by, giving us negative x squared minus 3x plus 28. That is the original problem.